I mean, I don't want to claim that, Solidity is like 100% safe. You can't claim that, but there is a lot of defensive programming that you can do to make sure that bugs actually don't get into real world code. And Solidity does this quite well, in my opinion, where there is a lot of invariance that the Solidity compiler inserts inside the code generation phase. And if these invariants are not satisfied, the compiler would just crash instead of generating bad code. So a lot of these bugs you discover are like compiler crashes. And this is also how we find a lot of bugs. We can force the compiler to try to break some of these invariants. I will talk more in detail during Istanbul Trust X. So yeah, if you are interested in this topic, feel free to check it out in Istanbul. But yeah, there is a lot of defensive programming in Solidity, and we use fuzzing heavily to try to break these constraints. And I was very fascinated to look at all these bugs. A lot of times they are like false positives, but I found the bugs to be extremely fascinating. And as I said, like the fixes are in most cases a single line of code, and making those fixes felt like very satisfying.
And again, I would like to ask for an example. Can you give us an example of like a bug that you fixed with a single line of code?
So many of them, but maybe I can talk about this one example of an optimizer bug. So there was this optimizer step which would remove jump tests that are unused. You can replace a certain jump test. Well, actually, what did it do? So it would actually replace redundant jump tests by a different jump test. So when Solidity generates code before the final assembly phase, the code would be in what we call like an abstract assembly syntax, where all the jump tests and all these references are still symbolic. You would just have a name instead of actually a value for all these jump test locations.
So instead of like the memory location, there is just names.
It's yeah, more or less, but so EVM at a high level, it doesn't have functions. So the way functions work is it's a jump.
With the sig hash, it's like a jump, and there is like the sig hash of the function with the parameters, right?
I mean, that is the ABI. So the ABI is how how it defines the external interface for the program. So even the internal, there is some internal interface as well. It's not standardized, but Solidity follows some standard, but it's not a public standard, so to speak. So Solidity would put a certain location in the code and then jump to that location. And this is called a jump destination. And there is some fun history behind. Yeah, there is a lot of fun history behind why jump test was introduced. Maybe if we have time, we can talk about it. But